Okay, this is an example problem of Newton's second law. Okay, the problem is a dog sitting on a sled is pulled across a floor by a rope connected to the sled. And the given values are mass equals 10 kilograms, mu sub k equals 0.2, the force due to tension is 25 newtons, which is 37 degrees from horizontal. The question is, analyze the forces. Okay, we're going to fill out this table, and the first force that we're going to analyze is the force due to gravity, and it is 0 in the x component because there's no gravity, and in the y component it is negative mass times gravity. Okay, the next force we're going to go over is the force due to tension, which is 25 newtons. Okay, well, we know there's positive 25 newtons and the cosine of 37, and the y component is also 25 newtons and the sine of 37 degrees also. Okay, next force we're going to use, well, that is applied to the box or the sled, is the normal force. And there's also 0 in the x component because it is going down, and the y component, it is positive normal force. Alright, and the next force we're going to go over is the friction force, and that is negative mu sub k and times the normal force, and the y component is 0. Okay, and this is going to lead us to the equation that we're going to go over, and the constraint is acceleration in the y direction is equal to 0, and that is going to lead us to figure out to find the normal force. And we're going to figure out normal force by this equation. Normal force plus tension sine theta minus mass times gravity, and that is equal to 0. Okay, and we're just going to reorganize this and put normal force equals mass times gravity minus minus the tension force sine theta. I'm just going to plug in the values that were given. So normal force equals 10, which is the mass, times gravity, which is 9.8, minus the newtons that were given, sine 37 degrees. And that will give you 82.95 newtons. Okay, and then we're just going to plug in the values into the table just to finish it. And the normal force is 82.95 newtons. And this is mu sub k is equal to negative 0.2, and the normal force is times 82.95 newtons. And last, it is negative mass times gravity, which is equal to negative 10 kilograms times 9.8.